So to get started, I think most people are probably familiar with chains. They've been around since we first were first software package to have them when Jurassic Park was released. And the idea is you go in, something rotates, you have a set of bones that rotate, and they also have a goal that reach this thing. So that's all very straightforward. In XSI, there are a couple things that may be different for those of you coming from other packages or coming from some of our older software. The first of which is the way they're parented. So what we've tried to do in XSI is set up the parenting of the chains so that the effector is a child of the root. So that's always going to mean that you can do a local animation here. So those coming from SI3D are familiar with that earlier workflow. You can set that by turning on SI3D skeleton drawing right here. So if I go draw a chain like that, you can see I've set up a little hierarchy here where the effector's child of the last bone. So the only problem is this is it's not very desirable for when you're animating locally, or if you animate this globally and you move from place to place. What this means is these keys are always in the space of your root. So as you rotate, everything makes good sense. So if I start saving a bunch of keys here, move this around, move this around, and move this around, I play that back. It's easy to move the chain around. If I go to my SI3D chain and start saving local keys. Oops. Yeah, key that. Key that. Actually, I gotta move it. Okay, key that there, key that there, key that there. It's a little more awkward to move around because you're moving the space. You're changing the space here, which is changing the space of there. So it ends up being kind of a mess. So this whole convention evolved actually of rigging, setting up a rig and gluing to it, and just constraining to the rig, and not having the IK separate from the rig itself. Something that we're slowly trying to defeat with new tools. So if we go in here and you can also reparent the effector. So I have this entire system child of this null here. We can go in and take the effector and cut that out and parent it, let's say in the space of this this parent node instead. So if I move this around, this will move locally, but then this one it doesn't affect. It's not changing the space of where you're solving to. So as I keep this, it's going to slide around and be locked in that space, whereas it will move, the space moves with this one. So you want to do that. Typically on some of the default rigs, you're having the hands be children of the hips. It just makes a lot more sense for animation. So the next thing, if we go in and start looking at some of the mechanical behavior of the chains themselves, I think the first thing to start with is the length. So in XSI you can go in here. Now it's always been a convention since chains first came out to go in and scale chains and to scale them up and down and to use this to have things extend in length. But the problem with that is, now sometimes this is useful, and it's still used in XSI. You can use that for a squash and stretch. You can use that for a lot of different techniques. But you can also come in XSI and you can change the length on any bone without changing the transform values. So it'll affect the position of this one, but you're not going to add any scaling when you change that length. And this ends up being a really good thing. For example, if you're doing character setups where you have characters morphing from one character to another, well, a lot of times you don't want to add scaling on the transforms because that'll inflate your points and cause all these other problems. So what you can do is you can go in here, just load up a little rig here and show you an example, and just stick it on the default guy. And if I go in and set them up here, you'll see what happens as I change the lengths. When I change the lengths, they pull in Oh, you got to go into your, let's look at the top mode here. So as I change the lengths, it's going to pull in the geometry, but it's not going to add shearing or inflate it. Whereas if I scale this down, you can see I'm adding scaling along, even if I do it non-uniformly. Well, non-uniformly I won't add scaling, but as this propagates down, you can get shearing, or you can get it goes on a different axis. The length is just a really good way to line up two characters and deforming into one another, for example.